Welcome everyone to my talk about HBase and Hive at StumbleUpon. I am Jean-Daniel Cryans. I work as a database engineer at StumbleUpon. Also, I have been an HBase committer since 2008, which makes me probably one of the oldest MySQL developers since the year zero was probably 2008. So how many of you have heard of either HBase or Hive? Alright, expected. Now, how many of you use HBase? Impressive. And how many of you use Hive? And now, who uses both together? One. Yeah, anyone else then? Alright, it's kind of interesting. So I meant this talk to be more introductory rather than going in the depths of using both, because once you understand how they were integrated, it's really not different than just using Hive, except that you have to understand some things that make HBase so special. So this is how it's going to go. So we're just going to go over what's HBase, how does it work, what's Hive, how does it work, and then how they were integrated together. And then I'm going to talk about how we use it at StumbleUpon. I'm going to give you some of the data flows, how the data is flowing into Hive, and then like how we did the mapping on our HBase tables. So first, nothing exceptionally new. Just what HBase is. So it's an open source distributed version, column-oriented store model after Google's Big Table. And this can be, I think this sentence can be found in Google's Big Table too, paper too. It has been used for a while for powering websites, such as StumbleUpon. We've been using it since the beginning of 2009, so we've been in production for over 2 years. We use it for basically as a MySQL replacement. So every time there's a new product that we ship at StumbleUpon, it will be built on top of HBase. We use it extensively for anything that's user-facing or analytics. You might also be aware of Facebook Messages, which is another big product that's using HBase. I won't talk too much about it since the presentation is right after me in the next room. So if you're interested in knowing more about it, you can see me go to Slack. So HBase can be used both in a real-time fashion, but also as a source or a sink to MapReduce jobs. It has many nice features, such as horizontal scalability. Because first it is built on top of Hadoop, you get Hadoop's nice scalability features. You add more data nodes, you will scale your cluster. It works the same way with HBase. You just add more region servers. The region servers will store their data into HDFS, and you get the same scalability. Then you have machine failure tolerance. The data nodes can die, such as the region servers. They can also die. The logs will be replayed, and things will go on. Then you have row-level atomic operations. So you have to be very aware that we cannot guarantee transactions on top of across multiple rows. The guarantee in HBase, you may call it ACID, depending on how purist you are. So you can do atomic operations on single rows, and those include compare and swap operations, such as check and put, check and delete, or increment counters. It's all built in. Then you have, HBase uses a object key value schema, so it's not just a key value, you have families. Each family can be seen as a map. So you will have key values, and then each of those values will be stored at a certain timestamp. You can use as many families as you want, though usually we recommend using only a handful. And each of those families will be configured separately. And also stored separately. This is where the column-oriented, people maybe call it sometimes family-oriented. So the families together will be stored in different files. So you want to store images and text in the same row. You may want to put them into two different families because they'll have different characteristics. The image is already a JPEG usually, so you don't want to compress it. But the text one, you want to compress it because it's easy to compress. And finally, you can access HBase through multiple clients. We have a native Java API. You can also use Thrift. You can use REST. And then through those tools, you can use pretty much any language that's supported. And now Hive. It's a data warehouse infrastructure built on top of Apache Hadoop. It was created by Facebook back in, I think it's late 2008 or early 2009. So if you have been writing MapReduce jobs before and haven't used either Pig or Hive, this is something wonderful that you can start using right now. So it will plug in on your data and let you use a language called QL that really looks like SQL, but it's not SQL. And then you can basically write your SQL, and then it will be transformed into MapReduce jobs that will run on your cluster, and then you'll have some answer. So you can use your own user-defined functions. It's very plug-in capable. You can use your own mappers, your own reducers, or you can just stay in the SQL world. There's different storage types. You can use the normal sequence file. You can plug directly onto CSV files. You can have RC files, which is sort of a column-oriented binary file. And you can use HBase. Not listed here. You can also use Cassandra. I think the storage handler was committed very recently. And then again, you can also access it through multiple clients. They have a neat shell. You can use JDBC. You can use Drift just to get your SQL queries. All right. So now, why would you put the two together? So the reason why you want to do it, and the first one is pretty much one of the reasons why we use it at StumbleUpon, is because you have a lot of data sitting in HBase. And you could be writing MapReduce jobs just to understand, like, do ad hoc queries on what's going on with that data. So just plug Hive on top of it, and then you can start querying that data right away. Also, if you have business analysts, which is, again, one of our cases, they usually don't code Java, and if you have business analysts that do, they're probably a programmer in a previous life. But usually business analysts can do SQL. So if you put that tool in their hands, they'll see the difference. They'll say, it's not exactly like MySQL, no, it's not MySQL, but it will do pretty much the same thing with much more data. And finally, let's say you want a storage solution. You want to do MapReduce. But if you do MapReduce, as you may know, the files in HDFS cannot be modified. So what would you do if you wanted to do MapReduce jobs, output the data, and then start playing with that data? Well, you will have to build something that really looks like HBase, because that's what HBase does. It will use those files that are immutable, and will handle all the updates, the deletes and the puts. So you want to have, if you use that data in a batch-oriented way, in a real-time way, then HBase might be the good storage handler for you and Hive. Reasons not to do it is you just want to take SQL, throw it out, and then put HBase and do SQL on top of it. That won't work, because it's still MapReduce jobs. So unless your users on your website are willing to wait a few minutes for every page to load, I guess not. This is not something you want to do. And then if you want to see interoperability with other analytical systems, so cubes and stuff like that, star schemas, it's not meant that way either. Alright, so now we'll dig in even more. So your Hive table definitions, they're not physically table. They're really just metadata about something that's sitting in HDFS. Same for HBase. HBase is also sitting in HDFS. So you can have, you can create a table in the Hive world that will point to an existing HBase table. Or you can create a table in Hive that will be managed by Hive and seen by Hive as if it was any other table that was stored in HDFS, Cassandra, HBase. But it will also be stored into the same HBase instance. What this means is you can have multiple tables that will point to the multiple Hive tables that will point to the same HBase table. So you can see them as views, but you can insert in them too. So you will have, let's say, one table definition that will point to some columns in your HBase table, and then you have another Hive table definition that will have some other columns, maybe some different names. You can create as many as you want. So this is how the schema mapping works. So in HBase, usually your schema is restricted to defining the families and their configurations, compression, is cached in memory or not, uses Bloom filters. But in Hive, you have to also give the types and you have to list every single column. So the example I'm giving here is if you have like a people or person table, it doesn't have to have the same name. It doesn't really matter. On the Hive side, you will have a column named name, you have a column named age, it will point to some column in the HBase table. In this case, the D would be the family, and then full name and age would be the column qualifiers, that's how we call them. So you can have a direct mapping, and Hive, you can give it basically any type you want. If it's not the right type, you'll get exceptions. And then another neat feature, as I said, you can view a family as a map, and the map data structure is supported, map type is supported in Hive, so you can consider a whole family as a map. And why? Because HBase tables can be pretty sparse. You can have column qualifiers that are totally different in every single row. So in this case, if you have siblings and the name of the sibling, or the name of the sibling is the column qualifier, probably that not everyone has exactly the same brothers and sisters. So in this case, you would treat it as a map. But there are currently a lot of drawbacks. The first one that may be biting you if you are already using HBase is the fact that you cannot use binaries. So let's say you want to represent integers only using 4 bytes, or you want to represent longs using only 8 bytes. For Hive, it considers everything as a string and then does the typing. So it will take the number and then transform it into an int. But if you give it binary data, it doesn't know what to do with it. So there's a journal named Hive-1634. There's a patch. You can try to apply it. You will have some bugs to fix. This is something we've been working on our side. Unfortunately, we haven't pushed back the patch that we're using currently because it's not exactly the way that the Hive or the developers want it. It's definitely some work we'll have to do, but it's a start. Another thing that's not supported is compound row keys. So very rarely in HBase you will store something with an incremental ID 1, 2, 3, simply because your tables will always grow in the same way, in the same sense, and only the latest regions will be the hotter ones, and the oldest region won't be written to. It makes it for very bad load distribution in HBase. So row key crafting is an art, and usually it means using some combinations of different keys. You will maybe have a user ID and then a timestamp, or you'll have 2 IDs concatenated together. And if you want to be, if you're really compact, you will use binary representations. So Hive here won't be able to parse your compound row keys, since it's not something that usually exists in HDFS files. You'll have just values one after the other. So we did some sort of hack at StumbleUpon to be able to use it. I'll show you later what it looks like. So it means that concatenated row keys are concatenated binary row keys are completely unusable. Let's say you have 2 integers in binary representation next to each other, 8 bytes. It looks like nothing for Hive. Also, filters. We have a cool suite of filters in HBase. So let's say you want to filter on the name of a column qualifier because you just want sort of the rows that have that qualifier. You can push that processing down to the region servers instead of doing it at the application level. Unfortunately, currently in Hive, this is all done at the Hive level, so all the data will be returned in the MapReduce job, and then this is where the filtering will happen. So eventually, it would be nice to push that down again to the region servers, or you can do it by hand. And finally, the partitions aren't supported. So, do people know what partitions are? It's usually a weird concept that people don't use. So some people say yes. So we have a very good example at StumbleUpon. We have this very, very big table that has data since StumbleUpon was founded, and that was in 2003. There's a lot of data. And usually we query that data only for a very specific time range. The thing is, it's not stored by time, because if you store it by time, you would have a table that goes only in one way, and again, the distribution would be pretty bad. So we have like some ID, time, and then some ID again. It means that you have to scan the whole table. Like, let's say you just want the last month's data. You will have to scan the whole thing, a few terabytes, in order just to get the few rows that you really need. So partitioning in Hive is really neat. It will store physically the data into different, well, if it's HDFS, in different folders or different files. So if you query by time, it will only use those partitions that were in that time. Well, if you define your partitions by time, it will only use the partitions that are in that time range and will not scan the rest of the data. In HBase, partitions are not supported yet. It means that if you want to have a very big table that's not keyed by time, but you still want to query it by time without going through all the data, it's not possible. So you have to either fake it yourself by putting your data in different tables and then doing multiple Hive queries and merge it all together, or you have to bite the bullet and scan the whole thing. Alright, so some things we do at Hive at StumbleUpon. Is there any questions before I continue? Yeah.
So how does the Hive handle the versions of the call values?
It does not. Currently, it does not play with the timestamps at all.
It just takes the most recent value?
Yeah. Well, Hive does not know it takes the most recent value because that's default in HBase. There has been some discussions with some guys in the back if you wanted to partition using the timestamps. Well, you could do that. Like, let's say the time is, instead of storing the data in different places, you really just consider a timestamp that's stored with every key value. The issue is that you still have to go through the rest of the data, you just won't be returning it to Hive. So it doesn't work as well as if you partition physically in different tables or folders. Did I answer the question? Any other questions? So data flows. We have data that's being generated in the StumbleUpon in many different places, like is usually the case with every company now. Everyone has data. It's flowing in from everywhere. So you have Apache logs, you have application logs, you have MySQL logs. In our case, we have HBase clusters. I meant MySQL clusters, HBase clusters. That data is growing all the time. Maybe you have other NoSQL systems. Maybe you have another thing throwing data at you. You have to put it somewhere, and you have to make it flow. Currently in Hive, we use data from all of the above except Apache logs. So how we move the application log files? So let's say you have this wild log file that's living in your system somewhere. So we'll have one job that reads them nightly, transform the format into something that's more usable in Hive, and then we'll dump it directly into HDFS. We have other processes that will tell the application log files because we need up-to-date data. We use a homegrown solution, but you could use something like Flume. It will again parse it into an HBase format, and then it will be sent into HBase, directly available for MapReduce jobs. For the MySQL clusters, we have a mix again of two different flows. We do CSV imports every night for the smaller tables that we don't really need to be up to date. Then we just dump them as CSV into HDFS, and then they're available, refreshed every day. We also use the tungsten replicator. So we're using MySQL application, like everyone does, but we have this dummy MySQL machine that instead of writing the replication log to a MySQL database, instead will use code that we developed to insert the data directly into HBase. So we have a constant stream of MySQL edits coming in that are available from MapReduce jobs.
Can you pitch that back to Tungsten? Is that available open source?
We still have work to do, but we would like to open source it.
Okay, but Tungsten's just Java, so it wouldn't be particularly ridiculously hard
To what?
to re-implement.
Yeah. Well, so the person asked if we could open source that. Yeah, so we did some sort of module that plugs into Tungsten, We could open source that module. It's actually in our plans. We just haven't come to it yet. And then finally, how we move the HBase data. So we have multiple clusters. We have a production cluster, which I will call HBase prod. And then we have a MapReduce cluster, which I will call HBase MapReduce. So one reason you don't want to mix the two together is that one is very sensible to latencies, and the other one doesn't care. It cares only about throughput. So if you don't want to have your website slowing down just because some of your analyst is running this huge MapReduce job that's training all the I/O for his job only. So you want to separate them. So we have two different clusters with two different type of SLAs. So what we do is we will, there's a MapReduce job shipped with HBase that's called copy table, very nifty name. And then we will just run that MapReduce job. It's like a discp for HBase, if you've used discp before. It will start a MapReduce job that will read in parallel from all the regions, or as much mappers as you can run in parallel. And then we'll insert directly into the other cluster. If you point to another cluster, or it can also point to a different table in the same cluster. In our case, we go from one cluster to the other. And then it copies all the data. You can choose to only copy between certain timestamps. So you will shuffle a lot of data, but you will only really copy the data that you need. We do happen to use HBase replication, so it's like MySQL application but for HBase. But currently, the replication that's available only works for one slave. So you have one master, one slave, and we're already using that for a backup cluster that's in another data center. So currently, we cannot plug that to directly move the data all to the MapReduce cluster. Although this is something I'm working on. So we will have always data that's always available on HBase. MapReduce, yes?
That copy table job, does that not affect the performance of your product?
Okay, very good question. Is the copy table job impacting the performance of the MapReduce cluster or the product cluster?
The product cluster.
The product cluster, yeah. So something that we tricked HDFS, we tricked MapReduce not to kill our cluster. So we set only one map slot and one reduce slot per machine. The machines have like it's two quads with 48 gigs of RAM and 6 disks. So they're able to take one mapper per machine that writes the data somewhere else. I usually, when people start copying table, I usually ask them to just ping me so that I open the right TSDB graphs to see if there's any impact, but usually there's no impact at all because sequential reads are pretty cheap. I answered the question, right? So the different use cases that we have at StumbleUpon. We have our front-end engineers. I didn't tell them how to use Hive, and then all of a sudden I was looking at my job tracker page, and I saw usernames that I've never seen before. And those were my engineers that just typed in some SQL. They knew how to get to Hive somehow. I didn't tell them, and they started running MapReduce jobs just to query the data that they moved from production to the MapReduce cluster, and then to understand what's going on with their products. So you can just really query any data that you have as long as it's in a queryable format, which means you have to fix something for the binary keys and well, the binary values and the compound keys. Our research engineers, they can run ad hoc queries to understand more about our users. So historically at StumbleUpon, we've only been doing data mining on either MySQL or Tokyo Tyrant. So once they knew that all the data was available in HBase, they also started running Hive queries to understand the behavioral patterns in our users. And then we have finally the business analysts that are trying to do their job, so to understand did this email campaign work? Were we able to get more stumbles out of the users to which we sent a reminder email or things like that. So this is what one of our tables, blocked users, this is what it looks like when you do the mapping. So we'll go through it together. So in this case, there's the very important keyword that's called external. When you use Hive, you can use Hive managed tables, which will, when you don't use the external keyword, Hive will just create a table. Or if it's a HDFS storage, it will just create a folder. In this case, I'm telling Hive to use a table that already exists somewhere. And then you have all the columns, and then you say start by, and this is the big little class name that you have to give to Hive in order to understand that it's stored in HBase. And then with sord properties, sord is something in Hive that the serializer that can tell how to basically parse certain fields. And in this case, you have to tell the column mappings. And it's pretty cryptic. So the first thing you have that's very important is the key. So unlike normal HDFS files, HBase has unique row keys. So you have, it's not a column really. The row key is stored along every value in HBase. So in this case, you have to consider it as a column. So they have this special way to identify the row key. In this case, it's column key. And then we have a family which is F. So you have a qualifier that's blocker, created. So they have to be in the same order as you define them. And then it will just use whatever type you said that was in there. If it's not that, then you will have parsing errors. It will usually show up as nulls. And then finally, you give the name of the table in HBase. In our case, it's a MySQL to HBase replication from the user db.stumble, and the name of the table in MySQL is block users. Also, please note that you don't have to map, as I previously, all the columns. As far as I know, I think there's like 5 other columns in the MySQL table, but we don't need them in this case. Now a more complicated table. So this is the ratings in HBase. So this is all the ratings of all the users, of all the web pages they've seen. So we have normal stuff, user ID, created, URL ID, rating, topic, and modified. Again, stored by HBase. And then we have like this very alien syntax here. So it's a trade-off. You could try to define user-defined functions in order to be able to parse certain columns that have multiple fields in it. And then in every SQL query, you would have to use those UDFs in order to be able to parse your data. So instead, we move that processing at the DDL level. So here we have a key. The pound B means it's binary data, and this is coming from Hive 1634. And then we have an @0. So this is a composite row key, and we have 3 different fields in it. We have 4 bytes, 8 bytes, and 4 bytes. As you can see, user ID, created, and URL ID. And then the position means where is it in the key. So it's a StumbleUpon specific hack. This is something I've written just to be able to parse those tables that have composite row keys. But this is how we do it. And then you have all the other columns, which are all binary data in HBase. So it's all pound B, pound B, pound B, pound B. That's what it looks like. Yes?
So it infers the size from the type of...
It does not. Actually, it's a very, very dirty hack.
Okay.
It could be neat. Like when I tell people about this, they say, "Ah, you can infer it," and yeah, you could definitely could. It's the next step, I guess. All right. So some metrics. This is a select star on our stumbles table. So all the stumbles from when the company was created in 2003. It's currently 1.2 terabyte after LZO compression on HDFS. So maybe 5x compression ratio. It used to take over 2 hours to scan it all when we had only 20 machines in our MapReduce cluster. We just upgraded to 80 machines with more disks and more memory and more CPU. So this is the TSD graph. I did this morning. So this is the TSD graph. And it shows the aggregate number of rows that were scanned per second on the cluster for the duration of the MapReduce job. As you can see, we were almost scanning 60 million on this go. So it's really 55 million rows per second on all the cluster at the same time. And then you see it tails off, so it means that some regions took a bit longer to scan, and eventually you have 3, 2, 1 mapper, and then the job is done. And it takes only 12 minutes. The business analyst is pretty happy because Stumbles is usually where he starts. So let's wrap it up. Hive is a good complement for HBase. All you need to know is SQL. But it is not a MySQL replacement. You cannot just use the queries you were doing in MySQL, do them on Hive, thinking that you can real-time access HBase through SQL. That's not how it works. And then the Hive-HBase integration is functional. You can do stuff with it, but if you really want to start using it in a way that you have data existing, it's binary, usually what you do with HBase, then you will have to get your hands dirty or paying. So in conclusion, I was thinking, like, how could you call HBase with Hive? Because it's NoSQL, but then you're doing SQL on top of HBase. Does that make sense to anyone? It's not SQL-ish. Alright, so the mandatory job slide. So if you don't have a job yet, or you're looking for a job, we have multiple positions open. We're in San Francisco, in the Soma neighborhood, next to the AT Park, close to Caltrain. That's it. Thank you very much. Questions? Yes.
Do you have any benchmarking for really complicated jobs, writing them in Hive versus just writing straight MapReduce? Seeing that way, I mean, is it equally getting performance per se, or?
So the question is, if we benchmark Hive queries against straight up MapReduce queries, we have not. Although if I use the row counter HBase MapReduce job and I compare it to a SetX star, the difference is almost nothing. Since really Hive Hive uses the table input format from HBase instead of it doesn't use its own table input format, so it's really just like you had a bit of user code on top of it. So the difference is not huge. On much more complicated queries, I guess you could optimize it even more to be more faster in MapReduce. But in Hive, it's like Java or C++. In Java, you can be a lot more productive in building shit. Other questions?
So the access pattern at the HBase level is HTable input format, not bits or scans?
Yeah, so the question is the access pattern, or what is used to access HBase from Hive. So it's the table input format. So, well, the table input format is really a scan. A scan, the start row is the beginning of the region, the end row, the end of the region. Yes?
But for inserts into HBase, it's using the put.
For inserts into HBase, it will be using the put. Yes, so you can definitely update the tables from the Hive queries and vice versa. So it's really using the normal HTable class. Yes?
Are you inserting anything directly from your web front end into HBase, or is it all go to MySQL?
The question is, do we insert the data directly into HBase from the front end? And the answer is yes. As I said, we're using MySQL less and less, and HBase is becoming the default store. So it's on all the critical paths now. So if there is no other question, you can feel free to see me after the presentation. I don't bite. Usually, nice. Thank you very much.